Okay, welcome. I can always tell when we get to the close to the end of the semester, there's more desk spaces that are open. But hopefully those of you who are not here today are watching the recordings, keeping on track. Either way, those that are here today can use those as well. But I thought we don't have we only have one more exam, and that's the final exam. Hopefully you saw the announcement I sent out. We do have our location. It's in Wexler A118, I think it is. Check the announcement though. I got a little map of where Wexler is in case you're not familiar with that. I'm going to look where A118 is because I'm not familiar. I don't spend much time in Wexler except for the second floor to get my copies, but I'll figure out where where that room is. It's and I've been in there maybe 2 or 3 times in the last 5 years, and it's easy to get lost. Let me just put it that way. But so you might want to take a look in advance. Where we're at is today. Where are we? We're going to talk about inverse functions. And so then on Thursday we'll go verifying identities, and notice we basically have one section from the text for each day. What I am thinking of doing is taking a law of cosines and combining it with law of sines, because they're both used for solving triangles. They're both used for the same purpose. It just depends on what information you have. In my online class, I have them combined into one sort of unit, and then we just, okay, here's a triangle, here's what we have. We have this much information, we use sines. If we have this much, we use cosines, and sometimes we use them both. Okay, so I'm going to integrate it that way. What that should do, if it all works, we've got after Thanksgiving, we've got a day to come back as a free day, so we haven't lost anything. But if we do pretty well in getting it covered, then that gives us a full week of review, okay, where we can look over things. By that time, I should know what the final's containing, and I'll work with you on that. So we should have a full finals week. Our class meets on Tuesday. Thanksgiving's not till Thursday, but I know Thanksgiving week itself is sometimes a little problematic because some people are traveling, and maybe you travel the week, to take it as a fall break. That's, however you choose. Oh, wait a minute. Maybe we've already got 2 things here. I'll take a look to see what we need to do. Sum and difference formulas. There's a couple of these where we could combine them without feeling overly loaded. Get them in one day so that we can maybe have the full review down here. If we get a little behind, if we need a little bit more, we can move those down there, so we've got time. Our final exam is Tuesday of finals week, so we don't have too much time in between, but we'll see as we get closer to that. Okay, I have finished scoring the exams. I have them with me, so after we finish today, if you want to take a look at yours, you can. Because the multiple choice questions get reused, I can't release them. What I will do, well, I hope to do, is over the weekend at least scan in the open answer type questions so that you can get a time to deeply review those a little bit better. Okay, but the multiple choice ones we can review here. We can discuss them and do all that. Okay. Any questions or concerns or things that you spotted that are happening in the homeworks that shouldn't be happening, or something, or due dates? We're all good? Okay. Yes?
I didn't get to start the homework till yesterday, and it's taking off the 15%.
Thank you. That's what I want to know. It's not supposed to do that, but sometimes I get those updated, and I say, okay, I'll get to that later, and I don't. So I'll get that set up for you. So yeah, no late penalties at all. So which section was that? Do you remember?
It's the 4.5 and 4.6.
6. Okay. So I'll look back and then I'll look at the other ones to make sure that those are out. typically what I'll extend it, but if I, yeah. So thank you. I'll hopefully get that done earlier in the day, if not later. Um, okay. So today we're slated to talk about inverse trig functions. So what is an inverse function? We've gone through a couple iterations of inverse functions. So just if I dig a hole, what's the inverse of digging the hole? Filling in the hole. So an inverse just switches the input becomes the output becomes the input. So it's just a reverse process is really what we're talking about. So before I go too much further, let's just think about what's sort of the forward operations. So if I have something like sine, we'll use theta, could be sine x, equals something. Should it be equal? Well, I guess we'll just say equals y. Now that could be confusing too. Let's say, equals triangle, but it's a number. What is theta? Physically, what is theta? What do we plug in to a trig function? Is it the cost of our milk? No. Is it the length of a side of a triangle? No. What? It's what? It's an angle, right? It's an angle, yeah. So what we plug in is an angle. Now, if it's in degrees, so maybe like 30 degrees, we plug that in. Or what would 30 degrees be in radians? That's pi over 6, right? So those are valid inputs into the function. So so sine has an input. And let's just go ahead. I'll emphasize it that it's an angle with the 30 degrees, because we usually do. I guess you could think that's temperature too, but in this case it's angle. What is the output? Sine of 30 degrees is, let's see if I can remember my unit circle. Is that a half? Right? Or is it square root of 3 over 2? I think it's a half. No. Yeah, it's a half. It should be a half. So what is this number, the output? Thinking of how we got to sine. It could be sine is opposite over hypotenuse, is that right? Did I get that right? SOHCAHTOA, yeah, so it's opposite over, it's the ratio of two lengths. It's a number, right? It's lengths. Well, it's not lengths, but it's a ratio, it's a number. Or it's a point, it's a coordinate, it's the y coordinate on the unit circle, right? But even that's a number, so it's a vertical height on a thing. So this is a number. It's not an angle. It could be a vertical, because it's sine, it could be a vertical height on the unit circle. Something like that. So let's think about when we go to, and we could do the same thing with cosine. Cosine is a left or right, a horizontal distance. It's an x coordinate on the unit circle and stuff. But when we go to the inverse sine function, where's the angle going to be? Is it going to be in the input or is it going to be in the output? Good, output. It's the opposite. So out here we're going to have theta. We're going to have an angle. Angle. Sometimes I spell it wrong, and you have angels. What's inside this is not an angle. It's the unit. It's a place on the unit circle. So actually, let's use our example. This would be sine of 1/2 equals 30 degrees. Okay. So that's a key part. What you plug into an inverse function is the unit circle answer. It's a number, and you get an angle. And it works the other way around. Okay. So let's walk through a few of these, and then we'll look through some examples. And basically, if we can remember the unit circle, it's just sort of reading this unit circle backwards. We've got the coordinate. We're looking for what angle goes with that coordinate. And notice that sometimes there could be more than one right answer. So what is needed for a function to have an inverse? Thinking back to that, if we think of the graph, what does the graph need so that it has an inverse function? A function has, each input has how many outputs? 3, 2, 57? Just one. Okay, good. Each input has only one output. So each x goes to only one y. If we're going to invert, each y also has to only go to one x, right? So it has to be a one-to-one function. Otherwise, this y could go to two different x's. That could happen. We need to pass both the vertical line test and the horizontal line test. So it needs to pass both the vertical and horizontal line tests. And if it doesn't, the graph does. Okay, if the graph doesn't, then we need to restrict the part of the graph we're looking at so that it does pass that horizontal line test. Now, because this is a class on functions, you can be guaranteed anything we're talking about passes the vertical line test. It's a function. But not all of the functions we've studied, quadratics, right, would pass the horizontal line test. They're not one-to-one unless we reduce it. And with the x squared, we reduce it to just 0 to infinity, and that's where we get the square root function, right? We're only using half of the x squared. So we're going to do the same thing. So what about the sine function? What does that look like? It looks like this. Does it pass the horizontal line test? Well, this horizontal line intersects the function in two places. That says it's failing. It failed the horizontal line test. So we need to restrict the domain. And typically when we're doing that, we like to include the part that's 0. So how could we cut this function up so that it includes 0, but it doesn't fail the horizontal line test? So this part's just going up. Right here I would start failing it. So how about if I cut it here? And then how much of the graph can I go back? This would still pass the horizontal. Down here it would fail it. So let's cut it here. If we restrict the domain to go from negative pi over 2 to positive pi over 2, we get a graph that passes the horizontal line test. So that's the key part. When we're talking about sine, the inverse sine, we're only going to use negative pi over 2 to pi over 2. There, from the text. Okay, from the notes actually. That's our domain. So we cannot talk about, if we've given an inverse sine of something, you can't say that it's pi, because pi is not in the domain, right? Can't give you that as an output. And we'll work some problems. But one of the key parts is, remember, the angle is the output. So anyway, yeah, we're going to restrict the sine graph to just negative pi over 2. So here it is, inverse sine. It's going to be, so we're going to look at that kind of graph. X is a vertical distance and y is an angle. So the output is the angle. The domain of sine itself will just be from -1 to 1. So remember, that's sort of the range here. Here's +1, here's -1. For the inverse, that gets flipped. And then the domain of this function of sine is negative pi over 2 to pi over 2. So on the inverse, that becomes the range. So x and y switch. So that's what we got going. That's the part of the sine graph. This is not the inverse sine. This is the part of the sine graph. sine of theta, sine of x that we use. And so the information, let's see, get this out of the way, I think. What we're going to be using is this half of the unit circle. Okay, so if we're at least using one of our standard angles, we can just look up the coordinate, the y coordinate, if we're talking sine, right? And then we can find the angle here. The thing is, this is set up to go clockwise, so what we have to do here is we have to change these to negative angles. So we'll actually, instead of 11 pi over 6, we'll call this negative pi over 6. Instead of 7 pi over 4, we'll just call this negative pi over 4. And we'll take out the 5, we'll call this negative pi over 3. And this one, we'll get rid of this part, we'll call this negative pi over 2. So we're just going to measure the angles negatively here. So if I get, I'll just throw in an example here. If we are asked to find the inverse sine of negative 1/2, the way we do that is we come to our unit circle, we look for where y equals negative 1/2. What angle is that? Oh, that's negative pi over 6. That's all we're doing, is it's sort of a reverse lookup. So far we said what is pi of negative, or what is sine of pi over negative pi over 6? We'd look it up and find the y coordinate, right? Now for inverse sine, we look for where the y coordinate is, negative 1/2, and that angle. Okay, so this is kind of I just copied and pasted this from one of the earlier modules of the unit circle, but we're just going to modify it. We're going to see that we use the same half circle for tangent, the inverse tangent as well. So this gets used twice. Does that just make, yes? Question?
From where do you understand which angle you should use? Which angle will be the inverse
Say that again?
Like how you find it pi over 6.
Oh,
Right?
because, okay, so since the sine is, we're looking for the inverse sine of negative 1/2, there's only one place we have negative 1/2, right? Up here is positive 1/2. If it was positive 1/2, then I look up, oh, it's pi over 6. If it's negative 1/2, it's going to be negative pi over 6. Okay, so it's kind of, I've just modified the unit circle to fit exactly what and all I'm doing is looking up, this number goes with this angle. Okay, we're also going to look at least one example where it's not one of these special angles, and then we can set up a triangle, and we'll do that type of problem too. Okay, so let's then just talk about cosine. What happens with cosine? It's also going to be the inverse sort of domain and range. Now with the cosine, I didn't do that horizontal line test, but if we go from 0, we get the graph that goes down, and notice cosine would continue, it would go back up, so we cut this part out, and over here this would go back down, so that would fail the horizontal line test, so we cut that out. So for cosine, we go from 0 to pi, okay, because that's sort of a continuous place where it's 1 to 1, so 0 to pi. So what part of the unit circle do we use? We use going from 0 to pi, and since that's how it works, we don't actually have to modify the unit circle. We just use the top half of it. We would not use the bottom half because that's where it wouldn't pass the horizontal line test anymore. So again, if we're given a question like what is the cosine of square root of 2, oh, not cosine, what is the inverse cosine of square root of 2 over 2? Notice what we're given is a number, it's not an angle. We are looking for the angle. Inverse cosine, input gets the number. So this time I look for where is the x coordinate, square root of 2 over 2. The angle that goes with that is pi over 4. So that's my answer. The inverse cosine of square root of 2 over 2 is pi over 4. Had it been negative pi over 2, I would have looked over here, and that would have been 3 pi over 4. Okay, so notice with inverse cosine, you're using the unit circle, but what you look for is the input is going to be the x-coordinate on the unit circle. The answer is going to be the angle that gives you that. Okay, and we use this because sometimes we have that value, right? We're able to solve using side lengths and stuff, but that will help us find out what the angle is. Sometimes we're able to measure the angle, and then we can figure out what the cosine is, right? So we have these two tools that we can use as needed. How are we doing so far? Is it kind of making some sense? Okay. It'll be, yes, sir.
How did you get cosine?
Inverse, -1.
No, how did you get negative square root of 2 over 2?
Oh, I picked that out. So this is what we would be given. So this might be a homework problem. They will give you this. You've got to come up with this as the answer. Okay. So yeah, and for any of the special angles, they could have said, what is the cosine of 1/2? And then we looked that up. Now in reality, we'll get working. You'll get that square root of 2 over 2 probably from some part of a problem, and then you'll need to take the inverse of that because they actually want the angle. So they might give you a triangle and give you side lengths, and that allows you to come up with that answer, but that's not what they want. They want the angle between those two or something. Good. Tangent, again, so we're just looking at how we're going to use these, and then this will integrate into some of the work we do a little bit later. If you tangent, I don't think I've got a graph of it, but if you remember, tangent will graph something like this, where it shoots off to infinity and it has asymptotes. And then it's a bunch of these, so this one's going to go from negative pi over 2 to pi over 2 as well. And so just like with sine, we use the same right half of the circle. They don't even do it. But again, when we come down here, what you're going to want to do is rewrite this as not 11 pi over 6, but negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Okay, so those will be our values. We also can use our calculator for these values and stuff, but obviously our calculator is going to give us decimal answers, not square root of 3 over 2 or something. Okay. The other thing is with tangent, one of the things you're going to want to do that might be helpful, because what is tangent? Not the inverse tangent, the tangent itself. Say that? Sine over cosine. So it's a ratio, and since sine is the y-coordinate and x is the, sorry, cosine is the x-coordinate. Notice, like for pi over 6, tangent's not going to be square root of 3 over 2 or 1/2. That's not going to be what we're given. It would be, so I'm going to speak specifically about, let's come down here. So tangent of pi over 6 is going to be 1/2 divided by square root of 3 over 2. So we're going to have to kind of simplify. This is 1/2 divided by square root of 3. When we divide by a fraction, what do? You flip and multiply. So notice I took the denominator, I flipped it, and I'm going to multiply, because that's actually what we're just dividing the two fractions. The 2's cancel. You get 1 over square root of 3. We rationalize the denominator, because this is what they like to do. There's another program that doesn't rationalize, so we get the square root of 3. Square root of 3 times square root of 3 is 3, so that would be a value. So the types of questions you get here is you'll be given that the inverse tangent what is the inverse tangent of square root of 3 over 3? We look on our unit circle, we don't see it, so you might want to say, okay, here's the tangent. Maybe we have to put that here. And then we would do this one, actually square root of 2 over square root of 2 over 2 divided by square root of 2 over 2. You invert, you actually, this one is going to be where the tangent equals 1. And this one, 1/2 gets out. This is just going to be square root of 3 here. Oops. So you might put these on your unit circle so that you can look them, you know, for at least the standard angles, you can look them up. So what we know is the inverse tangent of square root of 3 over 3 is going to be pi over 6. And we only have to do these 3 calculations because down here they will be the same, except they will be negative because cosine is positive, or the x is positive, sine is negative. So down here it would be negative square root of 3 over 3. This would be negative 1, and this would be negative square root of 3. Okay, and then at pi over 2, the y is, we're dividing by 0, so this is where it's undefined. So notice the parentheses here on the range. It's not defined at those endpoints because that would be division by 0. Okay, so that kind of happens. But again, we have to understand the tangent function, how that works. To understand the inverse is just doing it backwards, right? Whatever the output of tangent is, that's going to be the input of the inverse tangent. And anytime we have an inverse function, our output is always an angle. So pi over 6 or 30 degrees, depending upon whether they're asking for radians or degrees. Okay. And that's something when you do review your exams, take a look at. I didn't check them all, but sometimes you could be getting something wrong because you had your calculator in radian mode when it should have been degrees. I don't know how much we have you going back and forth, but that's something definitely to look at. Okay, so that's basically the lesson. Now we're going to look at some examples. And again, we could flip back and forth, but this is where, if we can remember our unit circle a little bit, think about it. So what's the inverse sine of square root of 3 over 2? We go back to our sine. Square root of 3 over 2, where is the y value? Square root of 3 over 2. Here it is, the y value is square root of 3 over 2. So what is our answer? Pi over 3. And notice this, you'll see this pattern with this inverse sine. Had this been negative square root of 3 over 2, it would be negative pi over 3. Okay, so those are the 2 possible answers. So you see square root of 3 over 2, it's either pi over 3 or the other one. So far, that, again, it's just going back to that unit circle, but reading it backwards. The input is the coordinate, the y coordinate. The output will be the angle. Same thing here. Notice it's negative square root of 2 over 2. Hopefully you remember, okay, that gets with pi over 4, right? But since it's a negative, it must be the negative pi over 4. Or 45 degrees, depending upon how they want the answer written. Negative 45 degrees. And that's just because we want that 0 in there, so that continuity, that's how we measure it. Okay. So far, so good? Okay, so that's sine. Got a couple examples with cosine. So cosine, what's the inverse cosine of 0? Remember, 0 is not an angle. This is maybe one that's hard because 0 radians, it could be an angle, right? But it's not, because it's an inverse, it's a number. Where is cosine equal to 0? It's not at 0. It's not at pi. It's a negative 1. the x-coordinate is 0 at pi over 2, right? And again, we could back up here. Oops, not too far. X is 0 at pi over 2. So it's kind of getting comfortable and used to this use of the unit circle, but I find it sort of helpful to have, well, at least 2 unit circles when we're dealing with inverses. The sine and the tangent one, and then you could make that into one, but on the tangent you want those ratios as we've got them, and then the cosine is separate because it's got a different input range, right? We go from 0 to pi. So we keep, I was trying to figure a way that I could impose the circle on. I couldn't come up, so we'll just kind of go back and forth, and hopefully I don't give anybody vertigo or anything because you get too dizzy from going back and forth. What did we say? Pi over 2, right? Or 90 degrees. Yeah, it's an angle. Inverse cosine of negative 1/2. Well, where's cosine negative 1/2? That's in the second quadrant. Negative 1/2, where x is, that's going to be, what that's, I think 5 pi over, no. Yeah, 5 pi over 6, right? Let's back it up. Oh, wait. No, that's where sine is. Cosine. See, that's the x-coordinate is negative 1/2. That's going to be 2 pi over 3. Does that make sense? So come back and, you know, because otherwise I was trying to do it in my head, and I got the first quadrant down pretty good, but if I get in the second quadrant, I mess up. Okay. So 2 pi over 3. Tangent, and remember this is one where you're going to want to make those ratios because you're not going to see them in the x and the y. It's the ratio of y divided by x. So square root of 3 over 3, we'll go back to our tangent. Here's our tangent. Square root of 3 over 3, we did that one. It's going to be pi over 6. So it's helpful that you know, at least for the 3 special angles we have, square root of 3 over 3 goes with pi over 6, 1 goes with pi over 4, and square root of 3 goes with pi over 3. Okay, so those 3 values should either be written down somewhere. You'll get, once you start using them through the homework, they will start to stick. Okay. And it's positive, so it's, yeah, that one's going to be, I forgot, that was pi over 6, or was it pi over 3? Pi over 6, thank you, which is 30 degrees. Okay, and then this one, negative 1, well, since it's negative, it would have to be in the 4th quadrant, right? Because tangent is positive in the 1st quadrant, so it's 1st or 4th, so it's in the 4th quadrant. And so this is where the angles are the same, or sorry, the x and y are the same. That's at 45 degrees, or in this case negative, or negative pi over 4. Either one of those. Depends on what they're asking. And sometimes they may want the angle as a degree, sometimes they may want it in radians, so kind of know those two go together. Okay, and again, you could flip back to your unit circle, but again, after you do that enough times, it'll start to sink in. So those are the easy examples. You ready for the harder? No, let's not do it. Okay. This is composition. So we're going to do 2 things, sort of backwards and forwards. So we'll just try this. And these are all, I took these out of the notes. So if you go into the notes, they've got them printed out and maybe a little bit wordier and stuff. So if, you know, you can read through them, that might make them clearer or get you there. So notice we want to do 2 things. First, we want to find the cosine. So notice this is an inverse cosine and a cosine of 7 pi over 8. There's actually 2 ways we can do this. I'm going to do it sort of maybe the harder way first because it'll sink in. We could look up 7 pi over 8. the angle, what is the x-coordinate of that, right? Because that's what that means. The cosine of an angle, 7 pi over 8. It's over here. That would be 7 pi over 8. Oh, we can't do it. It's not on the unit circle. I see why they did the way they did it in the notes. So we wouldn't be able to know exactly what that is. But is 7 pi over 8 within the domain of the inverse function? I mean, is it within the range? The inverse cosine, remember, it goes from 0 to pi, inclusive. The range does, the output. So 7 pi over 8 is actually smaller than pi, isn't it? Because 8 pi over 8 would be pi. So it's within this interval. What happens if you do something and then you undo it? It's the same. You get back to the beginning. Yes. You get to where you start. So that's what this one is. We don't know what the value is for 7 pi over 8. It's like a 15-degree angle or something. But what we do know is that we're going to do this and then we're going to undo it. So we don't really need to know that intermediate step. The answer to this is just going to be 7 pi over 8. Okay. Now, let me give you one more example to kind of show what happens. Inverse cosine of the cosine of pi over 4. Now this one we could actually walk through. What is the cosine of pi over 4? Isn't it square root of 2 over 2? If we looked on the unit circle, pi over 4 is square root of 2. So that gives us that we now have the inverse cosine of square root of 2 over 2. What's the inverse cosine of square root of 2 over 2? We look up the x-coordinate and find what angle it goes with. We would find that is pi over 4. Okay. So as long as we're within the range and we're doing something like this, inverse cosine basically undoes cosine and we're done. Okay. We're going to look at one with, I think, tangent, where we can't quite do that because it's not within the range, but that's one example. Inverse sine of sine, this is one where we can't quite. Is 5 pi over 6 part of the range of inverse cosine or inverse sine? Well, inverse sine, the range goes from negative pi over 2 to pi over 2. Where is 5 pi over 6? 5 pi over 6 is over here. It's in the second quadrant. It's outside of that circle. So we can't just say that the answer is 5 pi, that inverse sine undoes sine. We can't just do that. We have to kind of walk through. So what is the sine of 5 pi over 6? Well, what's the y-coordinate on the unit circle over here? I believe that is going to be 1/2. Right. The coordinates are square root of 3 over 2, 1/2. So this is inverse sine. Sine of 5 pi over 6 is 1/2, positive 1/2. Now we can find the inverse sine of positive 1/2. And where are we going to look that up? We're going to look that up in the first quadrant, where is y 1/2. I just want to So back here, y is 1/2 when pi is when the angle is pi over 6, right? And I cut off this one. I guess we could have seen 5 pi over 6 is 1/2. The y coordinate's 1/2. So we did we can get all of this off of the unit circle. Okay, so that's where we get that 1/2. We take the inverse sine of 1/2. We're actually at pi over 6, or 30 degrees. Because that's the only angles that we can use with the inverse sine. Okay. Does that make sense? It's tempting to just say, well, the inverse sine undoes a sine, and then the answer would be 5 pi over 6. But you can't have an answer of 5 pi over 6 for an inverse sine question. Inverse sine, your answers have to be limited to negative pi over 2 to pi over 2. Tangent. Tangent of 2 pi over 3, is that in the domain? Or the range, right? 2 pi over 3, where is that? That's over here. That's in the first quadrant. Remember, tangent only goes from negative pi over 2 to pi over 2. So we have to do the same thing here. We have to go look up what is tangent of 2 pi over 3. Does anyone know? Go back to this one. Here's 2 pi over 3. The tangent is going to be the ratio of these, right? It's going to be y over x. So square root of 3 over 2, negative 1/2. Let me go do my work over here. So this is square root of 3 over 2 divided by negative 1/2. You flip the 1/2, so the 2's will cancel. All right, square root of 3 over 2 times negative 2 over 1. So this is going to be negative 3. So that's the inverse tangent of negative square root of 3. Okay, so I did the inside part first. And now what's the inverse tangent of negative square root of 3? Where is tangent negative? First quadrant or fourth quadrant? Fourth quadrant, right? Because that's fourth quadrant. Cosine, or the x's are positive, but the y's are negative. So we are in the fourth quadrant. Remember, we are limited to negative pi over 2 to 2. Negative square root of 3 over negative square root of 3 relates to negative pi over 3. We could go onto the unit circle and look it up. Okay, so we kind of go back and forth with those. But I would, one thing I would do is I would sit down and make up these different unit circles. I would make the tangent ratios along with the x and y coordinates, so that you don't have to kind of do this calculation multiple times. Do it once and have it there, so that you start to recognize, oh, negative square root of 3, that's a pi over 3 or negative pi over 3, depending upon whether it's positive or negative. And this one, let me erase this part. So we can also do compositions with sine and cosine, and again, they don't undo each other directly, but now what we can do is we find out what is the inverse cosine of negative 1/2. That's going to be in the second quadrant, right? And that's going to be, if we look at our unit circle, I believe that one is 2 pi over 3. So what we end up with is sine of 2 pi over 3. And then what's the sine of 2 pi over 3? That's the y-coordinate of that place on the unit circle. And if I'm not mistaken, that's going to be square root of 3 over 2. Positive square root of 3 over 2. So it's just kind of piece by piece. We do the inside part first and then the outside part. Explain what?
Can you explain that?
Sure. So first what we do is we take the inverse cosine of negative 1/2. So again, what I come back to the cosine. Negative 1/2 is an x coordinate here, so that's a cosine. Cosine, the angle, the inverse cosine gives me the angle, so it's giving me the angle of 2 pi over 3. Right? And so now I take the sine of that angle. The sine of that angle is square root of 3 over 2. So that's how I end up with this. So it's basically just use the unit circle. This I'm using it backwards to take the x coordinate, find what the angle is. Then once I have that angle, I can take the sine of that angle and I will get the final value. Okay, but it's, have a little card with, or maybe a sheet of paper with all of these that you can use as reference, and then hopefully over time these values stick in your mind. If not, remember how to recreate the unit circle, and that might be a good thing to do when we come to the final. Go ahead and recreate it. I will give you a template. We'll have the template. It's either on the exam, or if not, I'll make one that I'll make sure you have a template so that's easy to fill in and get all your values there. I think we have one more. This is our so this is a case when we don't have a special angle. This is going to be the harder one. I think this is our last example to take a look at. What do we do when it's not a special angle? So we can't look up negative 1/6 on the unit circle because we don't have a special angle for that. There might be. I mean, obviously there's an angle that goes with it. So what we do with questions like this, and then also we're talking secant of it once we get done. So we use the inner side. So we're going to just really focus on this part. This is telling us that this is the angle that goes with a sine that has an answer of negative 1/6. Negative 1/6 is a sine. So that is a y-coordinate somewhere on a circle. We can create this triangle. Negative 1/6. Remember, what is sine? Sine is opposite over hypotenuse. Right? Did I get that right? Sometimes I get it wrong. Okay, opposite over hypotenuse. It's negative, so it's got to be either in the third quadrant or the fourth quadrant. We can't get the inverse sine in the third quadrant, right? So it has to be over here in the fourth quadrant. So we'll draw a triangle. Got a central angle. We know that from this angle theta that the opposite side is -1 and the hypotenuse is 6. Does that make sense? Okay, so we take that fraction, and that's opposite over hypotenuse. We make the triangle, and then we can figure out what the x-coordinate is here using the Pythagorean theorem, right? 6 is the hypotenuse, so that means that 6 squared is equal to -1 squared, which is going to be that, and this we'll call x squared. So x squared plus 1 equals 36. Subtract 1. X squared equals 35. Square root of both sides. X is equal to the square root of 35. That's our adjacent side. Now when I take a square root, I could get a plus or minus answer, but since I know I'm in the fourth quadrant, cosine is positive, so that's why it's important to know where we're at. So with sine, we're either inverse sine, we have to be either the first quadrant or the fourth. Since it's negative, it's in the fourth, so this number has to be positive. So now that I've got my triangle, I don't need the angle, but I could say that the secant of whatever that angle is, what is secant? Secant is 1 over cosine. That's how I remember it. What is cosine? Cosine is adjacent over hypotenuse. Since it's in the denominator, it's the reciprocal of that. So secant is going to be simply the hypotenuse over the adjacent side. From my triangle, the hypotenuse is 6. The adjacent is square root of 35. And that's sort of a right answer, but they like us to rationalize, right? Square root of 35. Square root of 35. So I'm multiplying by 1. And so my final answer would be 6 square root of 35. Square root of 35 times square root of 35 is 35. So they're the same values, but that's what I would put. So I can do that anytime we don't have a special angle. And again, when do we know we have a special angle? 1/2 square root of 2 over 2. Square root of 3 over 3. That would be nice. Square root of 3 over 2. So that's all. They're all over 2. Those are our special values for our angles, and if it's not one of those, we're having to use this method where we set up the triangle. Okay, I remember that was kind of one of the hardest things for me to wrap my head around and to do it. But just remember that fraction is giving us 2 sides of a triangle. And then we have to use the Pythagorean theorem to get that third side. Once we have all 3 sides, we can do any trig function. Okay, so there'll be some like this in the homework using this inverse. But again, when we're doing this, a lot of this it's just very abstract. It's just kind of building a skill to be able to work with trig functions, trig inverse functions, compositions of them, and what it's going to do is going to help us down the road when we're actually solving problems. We'll get to the law of sines and law of cosines where we'll be able to solve for all these different things. Sometimes we need to go, again, depending upon what they give us, we have to go to an inverse function to get the angle because we want to know that angle, right? That's where we're going to use this. And we're done with the lecture part. And again, this really mimics the notes very well. So the other thing is if you pull up the notes, you will see these also solved, probably nicer well, they're typed, so it's not handwriting. And there's words in there so you can read and it'll explain them a little deeper. Because sometimes we learn from hearing it, sometimes we learn by reading it, and some of us need a little bit of both. So that's what I get. So in here, it's more oral, visual and auditory, you're hearing it. Look at the notes, you'll get the reading, the seeing it on paper. That will help you build it, and then do the homework assignments. We'll build that knowledge, and then we'll go from there. Good, and we still have at least 15 minutes. 20 minutes if you want to stick around. I've got the exams. If you want to take a look at yours, you can come up here and we can do that. And then I've got office hours. Somebody from my other class is going to come, so I'll hang out here as long as I can.